Hi everyone. Okay, another long one today, but I think it's good for us to get practice with dealing with this parametric and vector functions as related to calculus. So today we're going to talk about parametric and vector accumulation. So let's do number one here. If x equals e to the 2t and y equals sine of 3t, find dy dx in terms of t. Well, that's pretty simple. We did that in our last lesson. X prime is going to be equal to 2e to the 2t. Y prime is going to be equal to 3 cosine of 3t. So dy over dx is just equal to 3 cosine of 3t over 2e to the 2t. All right? Number two, write an integral expression to represent the length of the path described by the parametric equations x equals cosine cubed of t and y equals sine squared of t for 0 is less than or equal to t is less than or equal to 2 or pi over 2. Well, if we're asked to find a length of a path, all we're asked to do is find our arc length there. And for that, we're going to need our derivatives here. So our derivative of x is 3 cosine squared of t times negative sine of t. And our derivative of y is 2 sine of t cosine of t. So our arc length is equal to, well, we're going from 0 to pi over 2, the square root of our derivatives here. So the square root of negative 3 cosine squared t sine of t, quantity squared, plus 2 sine of t cosine of t, quantity squared, and don't forget your dt. And we were only asked to write the expression. We actually weren't asked to solve this, so we're done with that. For number three, what values of t does the curve given by the parametric equations x equals t cubed minus t squared minus 1 and y equals t to the fourth minus 2t squared minus 8t have a vertical tangent? Okay, well, if we're going to have a vertical tangent, we need to know first our derivative. So x prime is equal to 3t squared minus 2t. And y prime is equal to 4t cubed plus 4t minus 8. So dy over dx, which is how we find our derivative of parametrics there, is 4t cubed plus 4t minus 8 over 3t squared minus 2t. Now, when are we going to have a vertical tangent? We're going to have a vertical tangent when our denominator here is going to be equal to 0. So 3t squared minus 2t is equal to 0. I can factor out a 2 or a t. I get 3t minus 2. So when t equals 0 and when t equals 2/3, we have vertical tangents. All right? Okay, let's move on to number 4. We're asked to find the equation of the tangent line to the curve given by the parametric equations x of t equals 3t squared minus 4t plus 2, and y of t equals t cubed minus 4t at the point where the curve equals t equals 1. Well, if we're going to write a tangent line, we're going to need our slope. So x prime of t is equal to 6t minus 4, and y prime of t is equal to 3t squared minus 4. So dy over dx is equal to 3t squared minus 4 over 6t minus 4. And if I evaluate that at t equals 1, I get 3 minus 4 over 6 minus 4, so I get a negative 1/2. All right, so we've got our slope here. Now we just need our point. So x of 1 is going to be equal to 3 minus 4 plus 2, which equals 1, and y of 1 equals 1 minus 4, which equals negative 3. So I've got the point 1, negative 3 in my slope. Now I can write my equation. Y plus 3 equals negative 1/2 times x minus 1. And I would just leave it like that. I wouldn't expand it or move anything around. Number 5, if x of t is equal to e to t plus 1 and y equals 2e to 2t, are the equations of the path of a particle moving in the xy plane. Write an equation for the path of the particle in terms of x and y. Well, all that this is asking is for us to basically eliminate the parameter. So if x is equal to e to the t plus 1, plus 1, I should be careful about that. Y is 2e to the 2t. I'm going to write x in terms of t. So x minus 1 equals e to the t. Natural log of x minus 1 is equal to t. So y is equal to 2e to the 2 ln of x minus 1, which you can rewrite as 2e to the ln of x minus 1 squared, which is ultimately just equal to 2 times x minus 1 quantity squared. All right, so now you've written in terms of x and y. All right, a calculator problem. This will be fun. A particle moves in the xy plane so that its position at any time t is given by x equals cosine of 5t and y equals t cubed. What's the speed of the particle when t equals 2? Well, first we need to find our derivative, right? So x prime is equal to negative 5 sine of 5t, and y prime is equal to 3t squared. Then we're finding this speed when x is equal to 2, or I'm sorry, when t is equal to 2. So x prime of 2 is equal to negative 5 sine of 10, and y prime of 2 is equal to, looks like 12. Okay? So now to find our speed, we're going to use that formula for the magnitude of our velocity vector. So we're going to have the square root of negative 5 sine of 10 quantity squared plus 12 squared, and I think you know how to type that into a calculator anyway, so I got approximately 12.3044. Okay? All right. The position of a particle at time t is greater than or equal to 0 is given by the parametric equations x of t equals t minus 2 cubed over 3 plus 4, and y of t equals t squared minus 4t plus 4. We're first asked to find the magnitude of the velocity vector at t equals 1. Okay, so if we're going to find our magnitude of the velocity vector, one moment here. What I first need to do is find the derivatives of these. These are going to be kind of awkward, complicated derivatives, but luckily we were told we can use a calculator here. So let's put in t minus 3 or minus 2 quantity cubed divided by 3. Oops, divided by 3. And I should probably have some parentheses around this. And then plus 4, and t squared minus 4t plus 4. Okay, and I don't need to actually graph this. I don't really care what the graph is. But what I need to do is find the derivatives. So, and I want to find them at 1, right? So I'm looking for v of 1 and what that equals. So I'm going to press math. And if I go to number 8, it's n derivative. So math 8. And here I can type in my derivative. So my derivative with respect to t of, and I can actually just use what I already stored in my y equals. So I'm going to say alpha trace x4 or x sub 1. And I'm doing this when t is equal to 1. And I get 1.003. So I'm going to put 1.000, right? And I can store that as alpha a. So I'm going to say store alpha a. All right? Okay? And on my paper here, I'm going to say that x prime of 1 is equal to 1.000 stored as alpha a. Now I'm going to do the same thing, and I just like to copy it because I think that's easier. And I'm going to now choose y sub 1, right? And I get negative 2. And I'm going to store that as alpha b, just so we can kind of get that practice. So I'm going to say store as alpha b, right? So now I can actually find my magnitude. So the magnitude is going to be equal to the square root of a squared plus b squared. And I can type that in my calculator. So second square root of alpha a squared plus alpha b squared. And I get approximately 2.23607. Right? So there I found my velocity, the magnitude of my velocity vector. What about the total distance traveled by the particle from 0 to 1? Well, the total distance is going to be, so L is going to be the integral from 0 to 1 of, well, x prime is t minus 2 squared, and y prime is actually equal to 2t minus 4. Okay, we could have done that earlier, but we didn't. So the total distance is going to be that. So, oops, I need an equal sign there. T minus 2 squared to the 4th plus 2t minus 4 quantity squared dt. And if you put this in a calculator, you get approximately 3.81569. When is the particle at rest? What's its position at that time? Well, a particle is at rest when x prime of t is equal to y prime of t, which equals 0. So when x prime of t and y prime of t both equal 0, the particle is going to be at rest then. So when is that happening? Well, we can use this, set our derivatives equal to 0. So t minus 2 squared is equal to 0. So you get t minus 2 equals 0, so t equals 2. 2t minus 4 equals 0. 2t equals 4, t equals 2. So at rest, this is at rest, at time t equals 2. So what's our position then? So our position would be equal to x of 2, y of 2, right? Which is equal to, and I can show you how to find that on our calculator. So I'm just going to say alpha x1 of 2, and I get 4. So that's equal to 4. And alpha f4 of y of 2 of 2, and I get 0. Okay. Now, obviously, those are probably simple enough that we could have solved them, but I just wanted to show you how to do that on the calculator and how that works. Okay, let's keep going. An object moving along a curve in the xy plane has position x of t, y of t at the time t is greater than or equal to 0, with dx dt equal to 1 plus tangent of t squared and dy over dt equal to 3e to the radical t. Find the acceleration vector and the speed of the object when t equals 5. Okay, we're going to use a calculator again here. So I'm going to enter these into the calculator. I get 1 plus tangent of t squared. Oops, did I forget my 1? Yep. Over 3 e to the second square root of t. Okay, and I don't need those, but what I do need to find is a of 5 is going to be equal to v prime of 5, right? So what's v prime of 5? Well, I can again use math 8, and I'm going to find my derivative of my velocity function, which is what I had put in earlier at 5. So I get 10.1786. And I can do that again for the y component. And I get 6.2765. Okay. So now I can use that information to actually find my velocity vector, or the acceleration vector, excuse me, And the speed, I found my acceleration vector, and now I need to find my speed. So my speed of v of 5 is going to be equal to the square root of 1 plus the tangent of, well, 5 squared is 25, plus 3e to the radical 5 quantity squared. And if I put that in a calculator, I get about 28.08277. Okay? Let's move to number 9. A particle moves in the xy plane, so the position of the particle is given by x of t equals t plus cosine of t and y of t equals 3t plus 2 sine of t. Find the velocity vector when the particle's vertical position is y equals 5. Okay, well, our vertical position is going to be when the x component is equal to 5, right? So we're going to say that, or not, I'm sorry, when our y component is equal to 5. So 3t plus 2 sine of t is equal to 5. So 3t plus 2 sine of t minus 5 is equal to 0. So now I can go to Math Solver, and this is when I'm going to type in 3t plus 2 sine of t minus 5. Okay? And I'm going to hit enter. And then I need to estimate about what this will be. And I'm just going to put in 1 and then hit alpha solve. And I get 1.079. So t is approximately 1.079007. And I'm going to store that as a. Okay? So I don't actually know how to solve this, how to store it from that screen, so I always just have to type it in. So I store that as alpha a. So now I can actually find the velocity vector. So my velocity vector is going to be equal to this derivative evaluated at a and this derivative evaluated at a, right? So I do math 8 of t of, and actually what I need to do is make sure I don't have the correct functions written in there, so I should do that before I move on. Make sure that I've got that. So back to here. So alpha x1 evaluated at alpha a, right? So I get 0.1185. And then again, I change this to my y component, and I get 3.9444. So there it is. There's the velocity vector. All right, another long one, kind of a free response type thing. So an object is moving along a curve in the xy plane, has position x of t, y of t at time t, with dx over dt equal to 2 sine of t cubed, and dy over dt equal to cosine of t squared for 0 to 4 of t. At time t equals 1, the object is at the position 3, 4. We're asked to write an equation for the line tangent to the curve at 3, 4. Well, of course, we actually have already... Pause. Okay, so we've actually been given our derivatives already. So dy over dx is going to be equal to cosine of t squared over 2 sine of t cubed. And we need to evaluate that at t equals 1. So we have the cosine of 1 over 2 sine of 1, which is approximately 0.321046. So now we actually have been given our points, so we can just write that line. So y minus 4 is equal to 0.321046 times x minus 3. Now we're asked to find the speed of that object at time t equals 2. Well, our speed is just going to be equal to the square root of our derivative squared, right? So 2 sine of, well, 2 cubed is 8 squared plus cosine of 2 squared is 4 squared. And if I put that in a calculator, I get about 2.08388. Hope you don't mind that I'm not actually... Hey, please don't be frozen. I hope you don't mind that I'm not actually putting this in the calculator because I already did it, but, you know, it's boring to watch me do that. Find the total distance traveled by the object over the time interval 0 to 1. Well, that's going to be, of course, our arc length again from 0 to 1 of 2 sine of t cubed quantity squared plus cosine of t squared quantity squared dt, and that's approximately 1.12600. Okay? And finally, we're asked to find the position of the object at time t equals 2. Well, the position, this one I really want us to pay attention to. The position of the object at time 2 is going to be equal to the position at time 1 plus the integral from 1 to 2 of our derivative that we were given. So in this case, 2 sine of t cubed dt. So this is going to be equal to, 3 plus the integral from 1 to 2 of 2 sine of t cubed dt, which after putting in a calculator is approximately 3.436206. Now I can do the same thing with y. So y of 2 is going to be equal to y of 1 plus the integral from 1 to 2 of cosine of t squared dt. And this is going to be 4 plus that integral, which becomes approximately 3.5569. So our position vector, so at time t equals 2, our position vector is equal to 3.436, 3.557. All right. Now, if I was given, like, here at time, let's say that initially I was given the position at time, like, t equals 4, and I was asked to find the position at t equals 1, it's okay to integrate backwards and, like, flip these around. So that would work as well. There's going to be one like that on your next check. I don't know if you caught that. On your next check, there will be one where you have to integrate backwards. But all right, so let's do some multiple choice here. An object moving along a curve in the xy plane has position x of t, y of t, with dx equal to cosine of t squared and dy equal to sine of t cubed. At time t equals 0, the object is at position 4, 7. Where's the particle when t equals 2? Well, this is really similar to what we just did. So x of 2 is going to be equal to 4 plus the integral. Well, that was at time 0. So, and we're trying to find it at 2. So we're going from 0 to 2 of cosine of t squared dt. And if I put that in a calculator, I get approximately 4.46146. And y of 2 is going to be equal to that position we know, 7, plus the integral from 0 to 2 of sine of t cubed. Throw a cubed in there. dt, and I put that in a calculator, and I get about 7.45194. And what matches up to that? Well, it looks like our close answer here is D. So that's it. That's our answer. All right. Number 12. The path of a particle moving in a plane is defined parametrically as a function of time t by x equals sine of 2t and y equals cosine of 5t. What's the speed of the particle at t equals 2? Okay, well, first I need to find my derivative. So x prime is equal to 2 cosine of 2t, and y prime is equal to negative 5 sine of 5t. So our velocity, the magnitude of our velocity, our speed here, is equal to the square root of 2 cosine of 2. This is at 2, so it's going to be cosine of 4 squared plus negative 5 sine of 10 quantity squared. And if I put that in a calculator, I get about 3.108. And that's our answer for B. Okay, good. Last two. Come on, don't be frozen. For what values of t does the curve given by the parametric equations x equals t cubed minus t squared minus 1 and y equals t to the fourth plus 2t squared minus 8t have a vertical tangent? Well, again, we're going to have to find our derivative. So x prime is equal to 3t squared minus 2t. Y prime is equal to 4t cubed plus 4t minus 8. So dy over dx is equal to 4t cubed plus 4t minus 8 over 3t squared minus 2t. So where do we have a vertical tangent? Well, we're going to set 3t squared minus 2t equal to 0. Can factor out a t, so I get 3t minus 2 equals to 0. So at t equals 0 and t equals 2/3, and is that an option? Yes, it is. That's where I have a vertical tangent. All right, and our last problem here. The distance traveled by a particle from t equals 0 to t equals 4, whose position is given by the vector s of t equals t squared t, is given by. How would we set up that distance? Well, our distance, our arc length, is going to be from 0 to 4 of the square root of our derivative squared. So the derivative of t squared, so v of t, the derivative of that is 2t, and the derivative of t is 1. So we're going to have 2t squared plus 1 squared dt, right? And it doesn't look like I have anything like that, so I can kind of expand a little bit, but this is going to be 4t squared plus 1 dt. And it looks like, oh, I do have something like that. There's a 2 pi though, 4t squared plus 1. There it is. D is our answer. Okay. Hopefully all of that made sense and you learned how to apply a lot of this. I think the most important things are how to use those calculator skills, and then also finding a position when you're given a velocity vector and a point at a certain time, and then finding a position at another time. So leave any questions you have in the comments, and I hope I get to see you soon. Bye.